Welcome to Supply Chain Management. In this lecture, we are going to start talking about distribution and network design. But before we jump into the distribution and network design, I would like to talk about some basic transportation, transshipment, and capacity models, which you will need to model when we talk about the network design aspect of this distribution network that a supply chain has. So let's go ahead and start working on this. So we are going to do a bit of math, a lot of Excel, and I would advise you to pay close attention to this module. So the models we're going to talk about are transportation, where supply is greater than demand, supply is less than demand, and supply is equal to demand. Transshipment, transportation with facility location, transshipment with facility location, and finally single sourcing models. So here are the different kinds of models we are going to discuss in this lecture. So the next step, we're going to look at transportation models. Here we're going to start with supply being more than demand, and then we're going to talk about supply less than demand, and then equal to demand. So let's take a simple example problem, really small toy problem. We have three factories, A, B, C, and markets, 1, 2, 3. Here is the transportation cost per unit, but essentially let's just look at this as variable cost. This could be production and transportation. This could require anything that is per unit cost. We can add it all up and put it right here. The capacity of these three factories are given 500 units, 600 units, 400 units, and demand is 300, 400, and 500. Like I said, this is a toy problem, and normally you're going to see capacity figures in 5 million or 6 million, but we're going to use small numbers so we can understand the problem. So the main objective here is to find the cheapest way to transport goods from factory to market. And as you can see, you add up the total capacity, that's 1500. You add up total demand, that's 1200. And therefore, you know supply is greater than demand. So when our first step is to model this problem mathematically, and I'm just going to show you the mathematical model more for you to be familiar with it, rather than you don't have to do it, you just have to do the Excel component. But the premise of how you're doing it in Excel is based on this math model, and I want to show you how to do that. So when we come to the math model, the first step is to define our variables, and what we call them as decision variables. And I'm going to use some very simple, intuitive ways of labeling what we call as our decision variables. And the decisions we have to make is essentially how many units should transport from A to 1, A to 2, A to 3, B to 1, B to 2, B to 3, and so on. And so here we have the number of units transported to each one. So I'm going to call it A1, A2, A3, B1, B2, B3, and C1, C2, C3. So automatically, if this is the number of units, our cost is going to be 30 multiplied by A1, because this is 30 per unit. You're going to transport A1. You're going to multiply 30 by A1 to get the total cost, right? Similarly, 50 by A2, 20 by A3, and so on to essentially get your minimization. And they are subject to two sets of constraints. The first constraints are supply side constraints, which are happening at the factory side. And essentially what you're saying is the total amount, A1, A2, A3 is the total amount which is being sent out of A, and that has to be less than 500, because 500 is the capacity. You cannot produce more than A, and you're not going to send all 500 because you can produce up to 1500, but what you really need is about 1200 units. So you're going to send only 1200 units, and that's why you have less than here. Demand side is A1, B1, C1. So everything that's going into 1, that's equal to 300. A2, B2, C2 is equal to 300. And A3 plus B3 and C3, everything that going into 3 is 500. And here you have to put equal to, because we have to meet this demand here completely, and we can meet it. And then finally, we have to say that A1 to C3, all of them is greater than or equal to 0. Now let's look at how we're going to take this big math model and try to put it in Excel. And I'm going to show you a very, very easy way to set it up and solve in Excel. So here we go. We have the data given to us. And the first step in Excel is to actually just copy this and paste it again. Let's delete the center. Let's delete all of this in the middle. And the reason I've color coded it here is that a lot of times people get confused. So the first thing is here, this is our actual supply. And you can say the sum of all these three cells is essentially what is being sent out of factory A. So we have that there. And let me just go ahead and the sum of these three, right, is factory B. So let's just go ahead and copy and paste the formulas here. And similarly, demand, or what is sent to market 1, is essentially the sum of these three, right? And so I'm just going to go ahead and format that, copy and paste right here. So we've got this here and this here. Now these here are what we call, and I'm going to go ahead and change the color here. These are called changing cells. So these are the cells which will actually contain the values that Excel will tell us how much to send from A to 1, how much to send from A to 2, and A to 3, and so on. So that's going to be an important component. Now your total cost is going to be essentially 30, right, multiplied by this value. Similarly, 50 plus 50 multiplied by this value, the amount you're going to send. Now it's going to take a long time if you have to do this. So there's an easier way to do it, and that function is called the sum product function. So sum product, we're going to select this array here. This contains all the cost, right? And here we have all the values you're going to use to send from one factory to what you're going to send from factory to market. And this will actually do this multiply. It's sum of the product of. So it's going to select the first cell here, multiply it times the first cell, then add it to the first cell multiplied by the second cell multiplied by the second cell, and so on. So here we go. We have that, and let's just go ahead and use our let's go ahead and do that. We have formatted it, and now we have to set it up on the solver. So in solver, our objective here is to minimize our total cost, and so I'm going to change that. We will minimize that, and the next step is these are the variables. Now you see how color coding makes it very clear, and we can select the right ones easily. So these are the decision variables, and we know supply constraints here. These values must be less than the capacity, and your demand, what you are being supplied, should be equal to whatever the market demands, right? And we also know that these values should be greater than 0. You can just go to engine here and click assume non-negative is true to take care of that. And once we have that, we can run the model, and this will tell you essentially it takes about 21,000. That's the cheapest way to supply all these markets. Factory B supplies market 1 and market 2. Factory A supplies market 3, and factory C supplies markets 2 and 3. Okay, and this is a simple example. We'll go through the other two examples very quickly, and then before we move on to transshipment. So we finished supply is greater than demand. Well, the next one, we're going to look at where supply is equal to demand, and you can see it's the same problem, except here your capacity is reduced from 500 to 200. And so you have 1200 is demand, 1200 is capacity. And the only thing that changes here, the minimization is the same, but you look at the supply side constraints and demand side constraints, you have equal to signs instead of less than or equal to here. So supply side, remember in the past had less than or equal to, right now has equal to. And with this, you are done. So let's quickly jump to the Excel file. I just want to show you the change you're going to make, and then we'll go on to the next example. So this model here, we essentially completed, and we got the solution where your capacity was greater than demand. So you're going to essentially copy this and create a copy, right? And click OK. So I'm not going to click OK. I'm just going to show you the differences. So here, all that changed is this 500 is now 200 here, and everything else remains the same. You go here, and instead of having a less than or equal to, you change that to an equal to sign, and then run the model again, and you get the answer. Here is another example where factory A has 500, but factory B is reduced down to 300. And again, you notice that we have equal to signs here. All right. So that's the only difference from greater than or equal to when supply is equal to demand. Okay, nothing else changes. Now we go to the third part where supply is less than demand. So nothing much changes. In this case, your total capacity is 1000, total demand is 1200. Everything else remains the same. So I'm going to jump through this, and the only difference is your supply side constraints will have an equal to, and your demand side constraints will have a less than or equal to. Because supply is less than demand, you will send everything you have, your entire capacity of 1000, but you will never be able to meet your demand of 1200. And that's why this is equal to, and this is less than or equal to. So if you go back to Excel, the only difference is that your supply side constraints are equal to, and your demand side constraints are less than or equal to. So you will notice here your demand side constraints were equal to. In this particular case, your demand side constraints are less than or equal to. And then if you run the model, you get your solution. So this finishes our basic transportation problems, and now we're going to look at transportation with capacity. Okay, so capacity planning with transportation is not very different, except that in transportation, we already have those factories already created. In capacity, we have the potential of having these factories, A, B, and C, but this capacity of 500, 600, and 300 does not occur until we incur a fixed cost of 100,000, 500,000, or 250,000. This fixed cost could be for building a particular factory. Of course, building a factory for $100,000 is really cheap. This is just an example problem, like I said, a toy problem. So remember that you don't have the capacity to manufacture 500 units unless you first spend $100,000. And this $100,000 is irrespective of whether you manufacture 1 unit or you manufacture 1,000 units or 100,000 units. It doesn't matter. Well, the capacity is 500, so you're not going to manufacture more than 500 units. But you have to incur this 100,000, and then you have these variable costs. Okay, so let's look at how we are going to handle this problem. So if you look at the variables, they're pretty much the same, except you have 3 new variables, A, B, and C. Each one is a binary variable. A is 1 if you have a factory in A, 0 if not. B is 1. If you have a factory in B, 0 not if not. And C is equal to 1 if you have a factory in C, and 0 if not. So while A1, A2, B1, B2, B3, C1, C2, C3 are all remains the same from the previous model, you are really dealing with 3 new variables, and they are binary variables. So the objective here is your variable costs are pretty much the same, but you add 3 new fixed costs: 100,000 A, 500,000 multiplied by B, 250,000 multiplied by C. And the trick here is if A is equal to 1, then you get this 100,000. You actually incorporate this 100,000. If A is not constructed, then A will be 0, and any number multiplied by 0 is 0, and so it will vanish. And let's look at the constraints. Your supply side constraints, essentially you have A1, A2, A3 is less than or equal to 500, just like you did a transportation problem. But now you will multiply A1, A2, A3 multiplied by A, and the reason is this 500 only exists if A is equal to 1. If A is equal to 0, this 500 disappears. So if you look at this, A1 plus A2 plus A3 is less than or equal to 500 multiplied by A. And if A is equal to 1, then this will be 500. If A is equal to 0, this will be 500 multiplied by 0. And so the sum of these three will be less than or equal to 0. And because A1, A2, A3 are all greater than or equal to 0, the only values which are both less than or equal to 0 and greater than or equal to 0 is 0. And so all these values will become 0, right? Similarly, B1, B2, B3, C1, C2, C3. The demand side constraints are pretty much the same, and you have integrality constraints. And then, of course, you have to say A, B, and C is binary, 1 if it's built, 0 if not. So let's look at how we model this problem from here. Let's go to Excel and look at how to set it up in Excel. All right, let's take a look at Excel. Now in Excel, you have these. This is your data given to you, right? This is the data given to you. And you notice that we have this capacity and we have fixed cost. This is a dollar sign, so let's go ahead and put that in. So I'm going to go ahead and copy this to the very next right here, right? And we can go ahead and delete this. And we can go ahead and delete this and this, right? And a lot of the things you did is going to be very similar to what you did in the transportation problem, with some small differences. First thing we're going to do is actually calculate the sum. This is pretty straight sum. This is all the material coming into the market. I'm going to copy this all the way right here, and we'll fix that. And then here the question is whether we're going to build or not, right? This is going to be 1 or 0. And then here you have the capacity. If you do build it, it'll be the sum of these 3 markets. And then you would have to copy this and paste functions, right? So you have the sum values here. The actual capacity is whether you're going to build something and then you multiply it by the capacity. And right now, since you don't have any buildings, your capacity is essentially 0, right? Make sure you have the formulas here. Then you have to go ahead and let's go ahead and set this up. Copy. And then we can set the values here. This is fixed costs, right? So essentially what I'm doing is I'm going to take each value here, multiply it times this, right? That gives you the fixed cost. And then I'm just going to go ahead and copy the formula all the way down. When you do that, you automatically multiply your fixed cost and your variable cost. Everything is there. So the total, I'm going to look at the total costs. And here you have the sum values. Right? You can copy this all across. Now, you don't really have to do this. It just allows you to break up your costs. You can pretty much go here. And if you have this, you can just add these three up, or you can just go here and say sum product, right? And you can select this whole thing, comma, sum product of this, and that will actually give you those values. So once you're finished, you've got the total cost. You're going to essentially, that's what you want to minimize. Your variables are right here. Your constraints are what you are selling from the factories or shipping from those factories is less than the actual capacity. And what you're getting in the market is equal to your demand, right? And now you want to make sure that this here, this is a constraint. It says it's a binary variable. You just select bin. And if these were, you can't have half a carton, if you can't have decimal values here, then you basically select them as integer. Of course, you've got to assume non-negative is true, and then you can run the whole setup. This allows you, it tells you to build your factory, all three factories. Your factory A is at about 40% capacity, operating about 40% capacity. The rest of it is 100%. Here are the items you are transporting. And then here is your total cost, $871,000. You fixed cost is $850,000, and then $21,000 in variable cost. And that finishes your model. So we finished transportation plus capacity. Let me give you a small variation here. In this particular case, we are told that we have capacity here of 500, 600, and 600, whereas in this case it was 500, 600, and 400. And you'll notice that when we ran this again, when we had 600 and 600, it basically said shut down factory A. You don't need that fixed cost, and you can do that. If you have higher capacity in factory C, you can do it at 869. And that's because 850 still comes from fixed cost, right? But your variable cost is here, right here. It's about 19,000. So unlike this, where it's 21,000, your variable cost reduces when you increase the capacity on factory C. And that makes it better with this total cost. With this, we'll stop transportation. We will go to a completely new lecture where we do transshipment problems.